So here we have a graph, and I'm going to put the ordered pairs here so you can see. So we've got 1, 2, 3, negative 3, 2, negative 2, 1, negative 1, negative 2, 0, 1, 1, negative 1, and it looks like 3, negative 1. We're going to first do this purple transformation, f of x plus 2 minus 1. Well, that purple transformation says we're going to go left 2 and down 1. So the left-right move affects your x value of your ordered pair, and your up-down move affects your y value of your ordered pair. So in purple, we're going to take the point negative 3, 2, and we're going to move it left 2 and down 1. So this point there we go. This point right here is going to go left 2 and then down 1. Okay, let's do that again. That's so much fun. Okay, this point is going to go left 2 and then down 1. This point goes left 2, down 1. In fact, all of the points go left 2, down 1. And then we're going to connect all these points, left 2, down 1. We're going to connect all these points using a straight edge so that it looks just as nice as the original graph. And there is your shift, left 2, down 1. Now let me show you. I'm going to try and oops. Let me try that again here. Doom, 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 doom. Okay, so what I wanted to show you, and I had to be a little specific here. I had to create that little tail right there so I could move it. So I just want to show you left 2, 1, 2, and then down 1. See how the whole graph moves left 2, down 1. So it's kind of a neat thing there, that transformation. Now what happens if I have the opposite of f of x? Well, the opposite of f of x is a transformation over the x-axis. So we're going to transform that over the x-axis. So I'm going to change my pen to red so that you can see those points. So when we reflect over the x-axis, remember x stays the same and y changes. So my negative 3, 2 becomes negative 3, negative 2. So we just flip it right over the x-axis. So this is a reflect over x. So each point will create a reflection over that x-axis. So it's going to appear to flip it upside down. And there's our red graph. So I might even use a highlighter to show that reflection. That's nice. The colored pens do it too. If you're working all in black and white, it's going to be hard to tell which is which, where one begins, where the other one ends. So I encourage you to please use some color so that you can see the two different on the same grid, unless you're going to recreate each one of these reflections on the same grid. I wouldn't do more than 2 on one grid. Okay, let's try one more here. We have f of 2x. Now remember, this is going to be a horizontal stretch. So this is a horizontal stretch. So what's going to happen here is we're going to take all of our x values and we're going to multiply them by 2, and then y stays the same. So negative 3, 2, negative 2, 1, negative 1, negative 2, 0, 1, 1, negative 1, and then 2, negative 3, negative 1, right? 3, negative 1. So I'm going to take each one of these x values and I'm going to multiply it by 2. So instead of negative 3, 2, I'm going to have negative 6, 2. So multiply the x value, multiply the x value by 2. So we'll have negative 6, 2, and we'll have negative 4, negative 2 times 2 is definitely negative 4, so negative 4, 1. I'm getting thrown off a little bit just because my graph is not exactly where it's supposed to be, if you can tell. Negative 1 times 2 is negative 2, so negative 2, negative 2. And then 0 times 2 is still 0. And then 1 times 2 is 2, so 2, negative 1. And then here we are, 3 times 2 is 6, so 6, negative 1. So you can see that stretch happening. In fact, I'm going to change the thickness of my pen so that you can really see it. So you can see that stretch happening. Yeah, this is pretty cool right here. So there's that horizontal stretch. Horizontal is left to right, and you can just see that it's been stretched out. Now, what's going to happen with my 1/2 f of x? So this time the 1/2 is on the outside. So that means we're going to take the y value and we're going to multiply by 1/2. So multiply y by 1/2. So let's make that, I like having that thicker pen. So negative 3, 2, if I take the y value and I multiply by 1/2, I'm going to get negative 3, 1. Okay. This we know is going to be a vertical shrink. So this is a vertical shrink. Negative 2, 1 becomes negative 2, 1/2. Negative 1, negative 2 becomes negative 1, negative 1. 0, 1 becomes 0, 1/2. 1, negative 1 becomes 1, negative 1/2. And 3, negative 1 becomes 3, negative 1/2. So we'll connect those points, and you can see how we have been vertically shrunk. And that's basically how your transformations work. So hopefully that was a good review for you with transformations. We'll mainly be using these with parent functions, but I like to use a graph like this because it not only demonstrates it well, but because then when you're faced with an odd looking graph that doesn't have an algebraic representation associated with it, you can still apply these same rules.